Okay, scholars, this goes on page 26 of your interactive notebook. We're going to talk about the introduction to domain and range. If you've copied these notes already, just make sure that you have them all. If you haven't copied them, make sure that you copy them now. Okay, so relations can be either continuous or discrete. Graphs of continuous relations have all the points connected. Discrete graphs do not. So if we look at this first picture here, this relation is continuous because it's connected by a line, which is this line here. Okay? The next picture, this relation is discrete because it is not connected. You all have to excuse my dogs. They are playing. All right. Shh. A relation is a relationship between independent variables, and your independent variables are your x's. That really does say that. And dependent variables, which are your y's. The domain of a relationship is the set of all values of the independent variables. In other words, it's the x values. The range is the set of all the values of the dependent variable. In other words, it's the set of all y values. Okay, let's look at this example. It says Andrea is selling snow cones over the summer. The first day she sold 5 snow cones and made $7.25. The fourth day she sold 12 snow cones and made $17.40. And her ninth day was pretty cool, so she only sold 2 snow cones and earned a mere $2.90. So the independent variable is the one that tells you what is being sold. So in this case, it's how much of what's being sold. So we're selling snow cones. So she sold 5 snow cones on the first day. She sold 12 snow cones, and then she sold 2 snow cones. And this is your domain. Then the money she made was $7.25, $17.40, and $2.90. And that is your range, because that, how much she makes, depends on how many snow cones that she sold. So your range is $7.25, $17.40, and $2.90. And you enclose those with brackets when you're listing them. Okay, this page is on these notes are on page 28 in your interactive notebook. You're going to want to make sure that you copy these down as well. Okay, so the domain and range for discrete relations. When you see this is going to be, you're going to see it as an ordered pair, for instance, on a graph. So your domain, we said in the other notes, are all of your x's, which are these. That's your domain. And you're going to write them down with a parentheses, with a bracket, 4, 2, 0, and -6. And then your range are the y's, which is 2, -6, 3, 2, and 7. And you're going to write those down with your brackets as well. So then it's 2, -6, 3, 2, and 7. I'm going to leave you to do this one on your own. Again, look at number 3. The domain. I should do that in red. Let me erase that. This is your domain. And this is your range. So for your domain, it is 1, 2, 3, 4. And the range is 5, 6, 7. And then I'm going to leave this one for you to do. Now, when we are looking at mappings, we're looking at this is your domain, and this is your range. So your domain is going to be this list, which is just simply -1, 0, 1, 2, and 3. Your range is going to be the number that your domain maps to. So you're going to whatever arrow. So when x is -1, y is 1. When x is 0, y is 0. When x is 1, y is -1. When x is 2, y is 4. And when x is 3, y is 9. And that's how you pick your domain and range out of that. And I'm going to have you do the next one on your own. Okay, to do this next part, you have to identify the points on the graph before you can get the domain and the range. So let's look at number 7. So when you're looking at your points, you always start at the origin, which is right here. And then it's always the rise over the run. So if we're going to this one, there is no rise, so it's 0. So when x is 2, y is 0, 2, and 0. Then for this one, when x is 1, 2, 3, 4, 5, y is -2, 1, 2. I'm sorry. Yeah. 1, 2. -2. That looks crazy. And then here, when x is -2, y is -1. And then this one, when x is 1, 2, 3, -3, y is 1, 2, 3, 4. And then the last one, when x is 2, y is 1, 2, 3, 4. So your x's are the domain, and it really doesn't matter where you start. So it's 2, -3, -2, 2, and 5. And your range is 4, 4, -1, 0, -2. And then I'm going to leave that one for you to try. All right. And the last page of notes for this particular section goes on page 29 in your interactive notebook. So this is determining if a relation is a function or not. What's a function? So a function is a special type of relation where each input or x value goes to exactly one output or the y value. Why do we care if a relation is a function? Functions are very reliable. There are families of functions that all look similar and behave in a similar way. So, determining if discrete relations are functions. Ordered pairs. If the same, we're right here. If the same x-coordinate occurs in more than one point, then the y coordinates are different, then the relation is not a function. So if you look, the same x's, so this is x and this is y, this is x and this is y, this is x and this is y, this is x and this is y. So I see that there are 2 5s in the x column. And if you want to make it easier, you can just make a t-chart, list your x's, 3, 5, -1, and 5, and list your y's, 4, -2, 4, and 8. And if there is a repeat in the x column, then it's not a function. So this is not a function because 5 repeats in the domain. Right? So let's do the next one. Again, it's easier if you just make a t-chart and put your x's first, which is 0, 8, 2, and -3, and your y's, which is 8, 0, -7, and 0. So we're looking here. There are no repeats. So yes, this is a function. Okay, no repeats in the domain. And I'm going to leave this table is just like the t-chart we just made. So I'm going to leave this one for you to do. Take a picture of each page and submit it online. I'll have a place for you to submit it in Teams. All right? Thank you.